Okay, so guys, now in this video we have to find dy by dx if y is equal to Euler x divided by Euler negative x plus 1. Okay, so we have two functions fx and gx right over here. This one is the gx. So when we have such a thing, we have fx in the numerator and gx in the denominator, we can use the quotient theorem, which says that first of all you have to write gx as it is, and then the derivative of the first function minus the first function as it is, derivative of the second function divided by the square of the second function, and this thing has been explained previously in other videos. Okay, so now let's just simply apply this rule. First of all, we will rewrite this function y is equal to Euler negative x plus 1, and we will simply apply the differentials on both sides of the equation, d by dx Euler x divided by Euler negative x plus 1. The second function as it is, now the second function is Euler negative x plus 1, then the derivative of the first function minus the first function as it is, derivative of the second function divided by the square of the second function. Then we have Euler negative x plus 1. The derivative of Euler x is actually the same, Euler x minus the Euler x. Derivative of Euler negative x would be Euler negative x, then the derivative of negative x right over here, because it is a function, negative x is a function, plus the derivative of 1 would be 0 because it is a constant. Write it Euler negative x plus 1 whole square. Alright, simply multiply this Euler x. So we have Euler x dot Euler negative x plus Euler x times 1 minus, over here this would be cancelled and we are left with negative sign, so this negative sign will be multiplied this negative sign right over here, and we have a positive sign. Now we are left with Euler x and Euler negative x, so when we multiply these two things, we have Euler x dot Euler negative x divided by Euler negative x plus 1 whole square. We have Euler x, when the bases are same, and they are being multiplied, then the powers will be added. So Euler x plus minus x plus Euler x plus, again the bases are same, the powers are added, so Euler plus negative x divided by Euler negative x plus 1 whole square. Then we have Euler, over here we can write x negative x because positive negative gives us negative, plus Euler x plus Euler x minus x divided by Euler negative x plus 1 whole square. This would be 0, right? X minus x is actually equal to 0. Then we are left with Euler power 0. When we have something power 0, it is actually equal to 1. Then over here again 1, so Euler x plus 1 divided by Euler negative x plus 1 whole square. So we have 1 plus 1 is 2, so Euler x plus 2 divided by Euler negative x plus 1 whole square. So this is the final derivative of that function.